I know how to be a good physicist. I think it's important to pose the right question and to answer it in the right way. It doesn't necessarily involve difficult computation. Sometimes it's the new idea that hits the point. I'm a theoretical physicist. We try to understand the most fundamental properties of quantum matter and how to leverage those properties to make our life better.
Certain materials show incredibly different properties that open up completely new horizon for future.
I work on 2D materials. Typically, there are 1 million electrons per square centimeter. They interact with each other. They exhibit exotic properties. We try to understand the collective behavior of those electrons. Superconductivity, quantum Hall effect, and ferromagnetism can emerge from the many electron behavior.
The normal kinds of states of matter you might be used to solid, liquid, gas. It turns out there's a lot of different, more interesting phases at lower temperatures, and in particular materials.
Inside the tool we use every day, pencil, there is a two-dimensional carbon sheet called graphene. We can specially stack those graphene layers to form a strongly interacting system. That system can exhibit superconductivity, quantum Hall effect at zero magnetic field, as well as semiconducting properties.
These phases are important because they're going to enable us to realize things like quantum computing.
Perhaps one day we can craft a quantum computer just using our pencil.
Dr. Zhang's discoveries in topological quantum matter have reshaped the field.
You need to be able to think about the next step, and we have to make physics reality.
I mainly study how electrons interact with light. So that means when I shine some light on the material, how it will respond.
A response of the material to light will become a two-dimensional map. And then we can use machine learning and achieve the deep optical sensing. We use a miniaturizer sensor to sense all the property, polarization state, the intensity, as well as the wavelengths simultaneously. We believe that deep optical sensing can actually be used for astronomy, medical research.
You can imagine many applications from healthcare imaging to astronomy.
In some star formation region, we can collect the light that it emits by analyzing the power, wavelength, and polarization. It gives us the hope to figure out what kind of elements are in the star formation region.
Dr. Zhang is an exceptional mentor who truly invests in his students.
I learn physics from my mentors. I also learn how to be a physicist from them. For my students, I try to understand what they are good at and try to cultivate them.
The best thing about Dr. Zhang is his ability to ask the right kinds of questions.
Dr. Zhang is a very innovative person, and we are learning new things every day.
When I see the type of work that Dr. Zhang is doing, I know that we are in the right direction.
Science is difficult. Sometimes you feel like you walk in a dark night. You can use your knowledge, intuition, and imagination to walk forward. So once the sunshine comes out, you know that's the answer.